everyone. Today let us learn few concepts of ninth basic concept, chemical symbols, valency and valence electrons. First, let us go through chemical symbol. They are abbreviations used in chemistry mainly for chemical elements and also functional groups and chemical compound. So as we all know, there are 118 elements in periodic table, and when you talk about a particular element, we are representing it or we are understanding it by its symbol. For example, if I write hydrogen, it's H, nitrogen N, calcium Ca, and so on. Okay, so usually these letters are derived from Latin, Greek, or German alphabet. Okay, some of them, and some of them are direct, like for example the ones I've mentioned here, hydrogen H, nitrogen N, calcium neon, they are directly obtained from either the first letter, first alphabet. If you look at the first, second, hydrogen and nitrogen, we are taking the first alphabet and putting it in caps. If not, we're taking the first and second alphabet, wherein the first alphabet is always capital and the second alphabet is small letter. For example, calcium, capital C and small a, and neon, capital N and small e. Similarly, some of the symbols, like for example, iron, okay, Fe, is obtained from Latin name ferrum, and sodium, its symbol is Na and it is derived from natrium. Potassium symbol is K and it is derived from kalium. So mainly these are obtained from its source. Okay, so wherever the source is or wherever it's carbonate ore or wherever we're finding it, because it's obtained in large amount, and because of its source in the world, it is given its different name. And similarly, some of the elements get their symbols based on the scientist achievement. For example, Einstein, because of Einstein, you name them as Es and it's called Einsteinium. And we have fermium, Fm, and mendelevium, Md. Okay, after the famous chemist Mendeleev, who designed the periodic table. Now, for your school, that is ninth standard, these are some of the most important symbol. Okay, I've taken it directly from the textbook. If you look at the symbols, okay, they are mostly like the first and the second alphabet. If you look at the first and the second row, and the third is going to be like a mixture of both, like nitrogen, oxygen, potassium, and uranium. Okay, so these are some of the very important symbols, and they are just some of the selective elements out of the 118, and these are usually repeated in the NCRT questions if you look at them. So that's why please go through these symbols thoroughly. Okay, it's more like learning part. There's nothing to by heart these concepts. Please learn them, right, and learn them just like how you solve your mathematics problems. Okay, so now the next topic would be atomic number. So let's understand what is meant by atomic number. So let's go with the definition. The atomic number of an atom is equal to number of protons in the nucleus of an atom or the number of electrons in an electrically neutral atom. Okay, so we will first understand this by knowing the structure of atom. So mainly students, we have nucleus. Just imagine the solar system. In the middle, we have the sun, the powerful energy. And around the sun, we have different planets, asteroids, meteoroids, and all of the other things moving around the sun. Similarly, when you look at the atom, we have the nucleus. So nucleus is the power behind the atom. So what is this nucleus made up of? It is made up of proton. Okay, we denote it as P plus, and neutron as N. So protons have a charge, positive charge. Okay, that's why I write it as P plus, and neutrons are neutral. Okay, and weight of protons is also heavy, and neutrons are negligible. Okay, but neutrons do play a very important role in the stability of an atom. Okay, so now around the nucleus we have small electrons which are very very light in weight. Okay, and they are revolving around the nucleus in specific path. So these paths are called as orbits. Just like how we have a road which connects from one place to another. Similarly, there are these orbits. Okay, they have a specific energy, and they are present around the nucleus. And on these orbits, the electrons are moving. Okay, in an elliptical orbit, in an elliptical manner. So now, for an atom to be stable, okay, so please understand that number of protons must always be equal to number of electrons, because electrons possess a positive charge, okay, electrons possess a negative charge, and protons possess a positive charge. For example, if I talk about let's say sodium, okay, sodium, what is happening, the number of protons is plus 11, okay, plus 11, and number of electrons will be, you can already guess it, it will be minus 11. Okay, so here we call an atom to be stable or electrically neutral because the number of protons and electrons are always same. Just like how you have plus 1 minus 1 is how much? 0. Plus 9 minus 9 is 0. Plus 11 minus 11 is 0, right? So just like that, here plus is what? Protons. Minus is electrons. So plus 9 minus 9. So that is the protons and electrons. Number is always going to be same. When they are same, we call such an matter as an atom. Okay, an atom is the smallest particle of a molecule or the smallest particle of a compound. Just like how we have cells in our body, right? Every cell constitute to make the organ system, then we have the organs and all of that. Just like that, you have the smallest particle as atom. Okay, atom is the smallest particle. Okay, so now coming back to atomic number. So now what is atomic number? Atomic number is going to be number of protons in an atom in the nucleus, or it is also equal to number of electrons in an atom. Are you understanding? Because as I already told you, protons electrons number should always be same. If they are different, then obviously it's not an atom, it becomes an ion. So in the next videos I'll be telling you about ion. So for now we are learning about atom. So proton atomic number is going to be number of proton, okay, in a nucleus of an atom, or number of electrons in an electrically neutral atom. For example, sodium, what is the number of proton, or what is the atomic number? Atomic number is 11. How did you know? Or what is it denoting? Atomic number, what is it denoting? It is telling me that, look, the number of protons in sodium is 11, and also the number of electrons are denoted as E minus because electrons have negative charge in them on them, and also the number of electrons is 11, right students? So atomic number is giving us a information, okay. And how is the atomic number denoted? It is denoted as Z. Capital Z refers to atomic number. Okay, so I hope this is clear. Now next, let us go move ahead with, yes, so this is a list of atomic number, again it's available in your textbook. So from first atomic number 1, that is hydrogen, to atomic number 18, that is argon. Okay, so 1 to 18 is given to you. If you learn 1 to 18, it's more than sufficient for ninth grade. As and when you proceed in your education, you can be learning more and more um, elements. Okay, so for now, it's going to be hydrogen is 1, helium 2, lithium 3, beryllium 4, boron. Boron is 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18. Now with atomic number, if you observe here students, number of proton and electrons are also the same, right? Just have a look. The same, these three tables are same. Okay, because atomic number is telling us the number of proton, and it is also telling us the number of electron. Okay, so this is the basic of the the structure of an atom. So please go to this thoroughly. Now the next we have is valency. So let's understand what is meant by valency. The combining capacity of an element is called valency, or I can also tell it as the number of electrons which an atom can lose or gain or share to attain stable electronic configuration is called valency. Now here I have mentioned a word, stable configuration, electronic. So what's the meaning? Just like how we have role models in our life, isn't it? So there's somebody in our family, like dad, mom, or somebody in our family, or maybe our teacher, who is like the best, like sure he can handle any situation, any difficult situation, or you can just go through any tough time and all of that. So there's kind of a role model. So similarly, so the role model for the elements is going to be the noble gas element configuration, and that's nothing but octet. So what is meant by octet? So octet is 8, 8 electrons. So where are these 8 electrons? Where should these 8 electrons be present? They should be present in their respective orbits. Okay, so orbit, what we call as the outermost orbit. So if I call this as the outermost orbit, so in this outermost orbit, how many electrons should be there? 8. Suppose if this becomes outermost orbit, let's say for some element, the second orbit is the outermost orbit. So how many electrons should be there? 8. Now why is it that the orbit is changing? Because atomic number is changing, isn't it? So for hydrogen, what's the atomic number? 1. So it will have only one orbit. For if you talk about sodium, 11, so then the number of orbits will go on increasing, isn't it, students? So it's just like that. So if there's only one student in the class, then he will be sitting somewhere in the first bench. Then if there are around 50 members in the class, then what, they you have to accommodate them. Yes, you four sit in the first bench, you three sit in the second bench, right? So the same way what happens is, when we talk about um, valency, okay, so it's always, we are talking about the electrons which are in the outermost orbit. Okay, and they, what is their criteria? They have a role model. What's the role model? To attain 8 electrons in the outermost shell. So that is called as valency. Okay, so I'll just go through the definition again. What's valency? The combining capacity of an atom, or the number of electrons which an atom can lose or gain or share to attain the stable electronic configuration. So here, lose or gain, what's the meaning? So suppose, let's say some atom is having more than or less than 8. Okay, so let's say this situation now. Let's understand with this situation now. So take let us take an example, that is magnesium. Okay, so what's magnesium atomic number? You can go through the text and you can refer the text. Okay, it's 12. So if I arrange them in the valence, if I arrange the electrons, okay, so whatever in the last, just observe the last, it will be having 2 electrons in the valence orbit. Okay, now is this 2 equal to 8? Definitely not, isn't it? Is 2 equal to 8? Definitely not. So what will magnesium do? It will donate, or what is it going to happen? It will lose the 2 electrons. So if it loses 2 electrons, what's the next orbit here? How many electrons are having in this previous orbit? It's having 8. It's so happy. I've got 8 electrons in the valence. This 2 electrons is unwanted or not required for that particular atom. So that's why it will donate. So that is what is called as losing of electrons. How many electrons it will lose? It will lose 2 electrons. Why it will lose 2 electrons? Because it needs to attain the stability. Okay, what's the stability? The stability is octet configuration or duplet. Okay, when the elements get duplet also, that is also stability. Or when the elements get octet, that is also stability. Okay, students, so that is the reason. Okay, this is how the valency is defined. How many electrons is lost or how many electrons is gained. Based on that, we define that particular term as valency. Now let's have another example, okay, wherein it's the opposite. See, oxygen. What's the oxygen atomic number? 8. Okay, so 2 6. Now here, observe the valence. There's a outermost orbit. It's just like writing like this. This is 2 electrons, 1 2, and here there are 6. 1 2 3 4 5 6. Now, tell me whether the oxygen, now it's 6, obviously 6 is not equal to 8, right? Now tell me whether oxygen will donate all the 6 electron, or it will gain 2 electron and make it 8 electrons. You're just smart. Rather than losing all the 6, because 6 is a larger number than 2, right? So what oxygen will do? It will accept 2 electron. Are you understanding? So accepting is nothing but gain. So when it gains 2 electron, how much is 6 plus 2? It's 8 electron. Now did it attain octet configuration? 100% it attained octet configuration, right? Are you understanding? So the previous example that I gave, magnesium, there it loses 2 electrons because the previous orbital is having 8. So there it's losing of electron. Losing of electrons, the atom becomes cation. Okay. Now in oxygen, what is happening is the opposite. It's gaining electrons because it already has 6. It's just, having 2 more. So just with the 2 more electrons, it will gain octet. So here it's gaining. So whenever atom gains electron, what happens to the charge? It is minus. Always remember. Okay, and whenever atom loses electron, it becomes plus. So here in magnesium, it's plus 2 because it is losing only 2 electrons. That's why plus 2. In oxygen, why ma'am minus 2? Minus 2 is because it is gaining 2 electrons. That's why minus 2. Okay. So this is what is called as valency. Now, according to that, what will be the valency of oxygen? It will be minus 2. What will be the valency of magnesium? It will be plus 2. Okay, students. So it's it's unique. For every atom, valency differs. It differs because atomic number also differs. Okay, so in 118 element, you can observe here. I've given the this thing, periodic table here. Observe the blue ones. They're all donate. They all donate electron because they're all metals. So metals in general, they always donate electron. So all their valency will be like plus 1, plus 2, plus 3, all that kind of valency. But look at the pink ones: helium, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon, all the pink ones. Okay, they are non-metals. So I've given the description here. Blues are metals, pinks are non-metals. So blues are metals means what? Blue have a tendency to lose electron because they have just, extra 1, 2, 3 extra electrons. They don't want, just like how I wrote for magnesium, they don't want that extra electrons. They will not attain stability. So they will donate. I don't want this electron. You please take it. They'll donate it to a much stronger atom. So that's why all the metals will get a plus charge. So if I call any metal as a M, general formula, it will be like M plus. But on the contrary, non-metals, what are non-metals? They are gaining. Okay, they will gain electrons because we observed in oxygen what happens. It had 6 electron, it wanted 2 more. So that's why gaining always becomes minus 2. Minus. Okay, so general I'll write gaining is always minus. So non-metals always get minus charge and metals always get plus charge. So this is the valency. I hope it's clear. So based on how much electrons are lost, that much will be its valency. For example, chlorine will gain 1 electron, so minus 1. Fluorine will gain 1 electron, so minus 1. Oxygen will also gain 1 electron, so minus 1. So they're all here. Observe, okay? Now they're all in this region. Similarly, lithium will donate 1 electron, so plus 1. Beryllium will donate 2 electrons, so plus 1, plus 2, sorry. Calcium will donate 2 electrons, so plus 2. Aluminium. Aluminium will donate 2 electrons, so 3 electrons, so plus 3. Okay, na? So it's that way. Okay. So this is all about valency and valence electron, and also about the chemical symbols. So I hope it was useful. Thank you so much.